Alright, so I'm first going to be going over the surface area of a cone. And you can see here I have a cone. Let me fold it up. It's a little cone. And I'm first going to trace out what we have right here. I'll do the base in a different color. Alright. So here we have our cone, and this red part's our base. And right here, this half circle right here, is actually going to be the lateral area. So you can see this part right around here, wraps out, and we can see that it represents our lateral area. So I'm going to draw a dotted line to show that this is our lateral area. And I'm actually going to go ahead and fill in the rest of this circle. Alright, so right here, this line right here, is actually our slant length, or our slant height. And our slant height is the part of the cone that goes from the top down the face of the cone. So not down the middle, but down the face of the cone. And we can see that that's the same thing as the radius of this bigger circle that we have right here. So I'm going to go ahead and write that down. This right here is our slant height, L. And then for our base right here, the radius of our base will be R. And we need to find this lateral area. And to do that, we're going to need a few things first. First, we're going to need the area of this whole circle. The area of this whole circle is pi r squared, but our radius is L. So pi L squared. And the circumference of this whole circle is 2 pi r, but again, our radius is L. So 2 pi L. And now we're going to need the circumference of the base. And our circumference of the base right here is actually equal to the part of the lateral area around the bottom. So that would be this part right here. This arc length right here is the same thing as the circumference of our base, as we can see from right there. All right, so make things a little easier, I'm going to call this part right here A and this part right here B, and we can say that AB arc length is equal to the circumference, which is equal to, and the circumference of this circle is 2 pi r, and this time our radius is r, so it's just 2 pi r. All right, now to find the lateral area, we're going to need a proportion. And let's take this circle for example. With this circle, we'll make this a sector area, and these circles are independent. This sector area right here, x, is 1/4 of the area of the whole circle, right? This area right here is clearly 1/4 of the whole circle. And also, this arc length right here is 1/4 of the whole circumference. So we see that this arc length right here is 1/4 of the whole circumference. And I can just tell that by looking at it. And if our sectors was the 1/2, then it'd be 1/2 of the whole area, and this arc length would be 1/2 of the whole circumference. So we see that these are always going to be the same proportion. So for this lateral area, for our purposes, our sector area is 1/2 of the whole circle. And the same thing for our arc length is going to be 1/2 of the whole circle. So we know that they're equal. So we can say that the lateral area divided by the area of the whole circle is equal to the arc length of this part divided by the circumference of the whole circle. That would be the circumference of the whole circle. So like we showed, 1/4 equals 1/4 and 1/2 equals 1/2. This part over this part is going to equal this part over this part. All right, so now let's plug in what we know. We don't know the lateral area. That's what we need to find. But we do know the area of the whole circle is pi L squared. And this part right here, this AB arc length, is also the same as the circumference of our base. And we know that that is 2 pi r. And we know the circumference of the whole circle is 2 pi L. So now we just need to algebra. These 2's cancel each other out because 2 over 2 is 1. Same thing goes for the pi's. And we're left with the lateral area divided by pi L squared equals r over L. And now I'm going to cross multiply. So L times the lateral area equals pi r L squared. I'm going to divide both sides by L. And one of these drops out. This goes to 1. This one, these two drop out, so we get the lateral area equals pi r L. And that's where we get the formula for the lateral area of a cone. So now that we've figured out how to find the lateral area of a cone, let's try some examples. So here, we've got a cone, and the radius is 6 meters, and the slant height is 15 meters. So the surface area is always the lateral area plus the area of the base or the bases. And for our cone, we just figured out that the lateral area is pi r L plus the base. And since our base is a circle, it's going to be the area of a circle, which is pi r squared. All right, so right here, we're given that our radius is 6 and our slant height is 15. So we already have all the information that we need. So all we need to do is plug it into our equation. So we have pi times our radius 6 times our slant length 15 plus pi times our radius squared, 6 squared. And now we need to simplify. So 15 times 6 is 90 pi plus 6 squared is 36 pi. So our answer is 126 pi meters squared. And it's squared because it's an area. All right, let's try another one. Make it a little bit more difficult. Okay, so with this cone, we're given that the height is 24 feet. 24 feet. And the diameter of the base, and that's this whole part, is 36 feet. All right, so again, the surface area is the lateral area plus the base. And our lateral area for a cone is pi r L plus the base pi r squared. And we need the radius and the slant length. And they gave us the diameter, and we know that the radius of a circle is half this diameter. So 36 divided by 2 is 18. And now we need the slant length. So to find this slant length, we're going to use a right triangle. And you'll see right here, we have a right triangle. So I'm going to go ahead and draw this off to the side. Right triangle. This part right here is the same thing as the radius, which we just found is 18. And this part right here is the same as this height, 24. So we're going to use the Pythagorean theorem. The square root of the sum of this one and this one, so 24 squared plus 18 squared. And when we plug this into our calculator, we actually get that this is 30. So our slant length, which is this part right here, or this part right here, is 30. Now we can plug that into our equation that we have. Pi times the radius 18 times the slant length, 30, plus pi times the radius squared. And I'm going to use a calculator here, and we get 18 times 30 is 540 pi, plus 18 squared, 324 pi, and we add it together, we get, oh, you can't see that, we get that the total surface area is 864 pi feet squared. And that's our answer.